In order to make a home as energy efficient and comfortable as possible, architects and contractors minimize the three properties of heat transfer: conduction, convection, and radiation. We will explore one of these three forms, convection, and investigate how it is experienced within an affordable housing project. Convection refers to the heat transfer between a moving fluid and a solid. Convection also refers to the movement of the fluid that drives this heat transfer. This movement can be driven either by natural convection or mechanically driven convection. When constructing a home, architects and builders commonly look at convection related to a gas with which we are all familiar: air. It is common for people to talk about convection in the home, but they usually refer to air transfer, which is not convection in its scientific definition. In a home, there are two types of air convection: natural convection and forced convection. We see natural convection when heated air around a stove rises to the kitchen ceiling. Or, when looking at a cup of coffee, we see energy rising from the cup as steam and hot air. Forced convection usually refers to the use of fans to move air and the heat energy contained in it. Although convection is a powerful force that affects the comfort and efficiency of a building, heat energy lost through convection cannot be thought of separately from energy lost through conduction and radiation.
The conductivity of air doesn't really matter when you get convection and radiation happening, because the conductivity of air is actually much lower. If you can stop the air moving, now you're closer to the conductivity of air, which is something like R5 per inch. When you start out with an uninsulated wall cavity and assume that you're heating the building, this is warmer than this, and so the warm air inside that cavity is going to rise because it's lighter weight. It's going to reach the top, and the air on the outside is going to be cooled off. It's going to fall, and that creates literally a loop inside that just drives the heat flow even faster. When we start putting insulation in this wall cavity, you put a thin layer of fiberglass or cellulose insulation, some kind of fibers in there. It's going to slow down the air movement so it stops that convective loop.
The gas inside a sealed double-pane window also experiences convective heat flow. This occurs when gas moves within the internal space and is independent of any air moving in or out.
In this project, as you know, we have to pass the Energy Star test. On our windows and doors, between the cavity is full with gas.
So one of the things they do inside this pane of glass is they'll add something called argon or krypton, which is a dense gas. It's denser than air, and it slows that convective process down so that it improves the thermal performance.
Convection's effect can also be seen on the external surfaces of a window. It can be driven by weather outside the structure or through the natural convection occurring inside.
Even if the window is completely airtight and perfectly weather stripped, people may feel that there's a draft there because the air gets chilled by the cold window surface. Cool air will fall, it's denser than the air in the room, and when it hits the windowsill, it gets diverted and it'll bounce out into the room a bit. It's not a draft of cold air coming in from outdoors necessarily. It may just be that ghost draft, that cold air that's falling and shooting out into the room.
In common language, we often use the term convection when we really mean air transfer. This is not heat transfer, it is the mechanical movement of air. This can be intentional movement within the building or driven by fans, heaters, or air conditioning. Unintended air leakage can be caused by leaky ductwork or the stack effect. The stack effect occurs when lighter, heated air rises. It escapes to be replaced by heavier, colder air from the outside. Air expelled from inside the home must be replaced by an equal volume of air from outside. This air must be heated or cooled to maintain a comfortable temperature. It can be important to remove air from inside a house for reasons other than to keep it hot or cold. Bathrooms usually have some form of vent for steam to help avoid mold. We might also want to expel bathroom air for other reasons too. An important step that can be missed during planning and construction is sealing potential leaks in the building envelope.
On the outside, we've got a house wrap that's designed as an air barrier so that it's stopping the wind flowing through the insulation. And we really have to be careful about the detailing where the house wrap stops at those interesting architectural details.
By putting the bicore on the exterior, it just gives it a much better sealing on the window. No moisture and no air penetration on those windows.
To ensure the units are properly sealed, the contractor is conducting a blower door test.
The blower door test, they pressurize the building with like 5 to 20 pounds of air pressure. And if the windows and doors and all the outlets are not installed right, you won't pass inspection because the building will be leaking air towards the exterior. But if you do it right, you caulk all your seal plates, make all the joints tight, you use the Tyvek, you use the bicore on the windows and the doors, you pass blower and door test with flying colors.
Minimizing natural convection and eliminating or slowing air leakage is an effective way of slowing heat transfer. Keeping the heat where you want it, inside or out, will save you money and make you more comfortable.